Welcome to qnawire.
So, an astronaut whose mission is to go to a distant planet and release a small rock from rest finds that it takes 0.48 seconds for that small rock to fall 1.90 meters. And so we're also given the radius of the planet, and then we're asked to find what its mass will be. So looks like probably the way we want to approach this is to use kinematics to figure out what the acceleration of the rock would be. And then we know how to relate the acceleration to the mass and the radius of the planet. And so given that we know the radius, we should be able to find what the mass is then. So could solve this a number of ways, but we'll go back just to our most basic kinematics equation, which tells us that the height as a function of time is equal to 1/2 of the acceleration times time squared, plus its initial velocity times time, plus its initial height. So applying that to the situation, we'll say negative 1/2 gt squared. So I'm using g as what the value of gravity on this planet is, and then I'm putting a minus sign here just because I want to find this as a positive value. So even though it's acting in the negative direction. Then it's released from rest, so there's no initial velocity, so just plus 0. And then the height is 1.9 meters. And then we know when it hits the ground, so that final height is then going to be 0. So we can solve for g here. And so we should get then that g is going to be 2 times h, that 1.9 meters, over t squared. And so plugging in 1.9 for h and 0.48 for t, we get that g is 16.49 meters per second squared. And so now we know that gravitational acceleration on a planet is just the gravitational constant times the mass of that planet over the radius of that planet squared. And so rearranging this a little bit, we would get that the mass of the planets is equal to r squared times g over big G. And so we know r, and then we just found g, and we know the gravitational constant. And so we find then that this is 1.83 times 10 to the 27th kilograms.